And
I have a question for you. How old are you? Oh, I see. You don't want to answer because you're an anonymous internet user and that's your private life. Well, guess what? It's not going to be private much longer. By January 1st, 2027, your operating system will need to know how old you are to connect to apps and websites on the internet. While you were focused on the Epstein files and all the arrests the government was making, your technocratic leaders around the world were all simultaneously busy with a new hobby: age verification laws.
How's your new computer doing?
Oh, good.
Yeah.
Yeah, I like it.
Age verification is nothing new. Every time you want to support indie filmmakers or play games like GTA 6, you need to lie on an age verification form like this. But that will soon become a thing of the past because age verification is moving down to the operating system level. That means anytime you get a new computer or phone, Windows, Mac OS, Android, or Linux will be legally required to collect your age. And not just that, but they also must provide an API where developers can query your age as the primary source of truth for access control on apps and websites. It's yet another big win for big tech, but luckily a hero has emerged: a single new Linux conversion script that says this aggression will not stand.
This will not stand. This will not stand, this aggression.
In today's video, you'll learn about ageless Linux and the battle against OS-level age verification. It is March 20th, 2026, and you're watching The Code Report. Back in October 2025, the Digital Age Assurance Act was passed into law in California, and it makes it a legal requirement to collect a user's age on any general-purpose operating system. And that puts the primary responsibility on Apple, Microsoft, and yes, Linux. Now, of course, this happened in California with every single lawmaker voting for it, and of course the reason to take away your privacy is to, quote, protect the children. As a parent, I'm all about protecting children, but parental control is already a solved problem. It's trivial for parents to monitor and control the content their kids consume, and OS level age verification won't change anything, so what is it really all about? Well, the end game here is to turn every device you own into something that only works when you log in and prove who you are. Your cell phone, your Wi-Fi router, and your smart toilet won't work unless, of course, you've age verified with your Apple, Facebook, or Google account. Once everything is connected and authenticated, it creates a system where every action, from browsing the internet to grabbing a beer from your smart fridge, can be tracked by default. In other words, it's just a Trojan horse for mass surveillance. On top of that, it creates a compliance moat for these big tech companies that hurts small developers and only benefits the massive corporations. Meta spent millions of dollars lobbying in California to pass this law, with OpenAI as a co-sponsor. Apple and Microsoft are just chilling on the sidelines as indirect beneficiaries, but the Linux community has mostly been silent and confused, except for this one chaos agent called Ageless Linux. It's a new distro, or actually no, it's just a script that is vowed to violate all age verification laws, even though violating the law is against the law. To get started breaking the law yourself, all you have to do is run this script on any Debian-based distro, like Ubuntu or Kali Linux. This script will modify the OS release metadata about your system. Then it will install some documentation telling the state of California that we will not comply with AB 1043. It'll then deploy an age verification API that doesn't work. Congratulations, you just became an operating system provider. Legally, you are a person who controls the operating system software. If a child uses this operating system, you are required by section 1798.501 subsection A clause 1 to provide an accessible interface at account setup that collects their age. Unfortunately, AddUser in Linux does not do this, so you could be fined $7,500 for any child in California who uses your operating system. When I was a kid growing up in California, the internet was a utopia of anonymity, but sadly, my kids won't even be able to use the internet without being first approved by big tech bouncers. On the bright side though, at least my kids will be able to write way better code than I ever could in the future, thanks to awesome tools like CodeRabbit, the sponsor of today's video. It's already the best AI code review tool out there, and they just launched a new feature that solves one of the biggest issues of our time: human conflict, or I mean merge conflicts. So instead of context switching between branches, trying to figure out what each side is trying to accomplish, CodeRabbit automatically detects any conflicts during pull request review and analyzes the intent behind both versions of the conflicting code from first principles. Then it pushes one unified commit to your branch that resolves everything, and if it's too ambiguous, CodeRabbit will decline and flag it for manual review, instead of just guessing. Try out CodeRabbit today for free at the link below.
so yeah, Linux is pretty awesome. And one thing, like some fun facts. So Windows is owned by Microsoft, or like Mac OS is owned by Apple. Linux itself is open source, which means that people like us can use it, install it as our own, fork it, or add some code to it. So since it's open source, as I said, you can contribute to it. So as a developer. And something also interesting is that this was built by someone named Linus Torvalds. And this guy also created Git. So Git was his side project while making Linux, which is, and yeah, Linux is like the best OS right now, or for a long time. And Linux is in like 50, 80 something percent of all devices. So if you guys have like Android, that's also Linux based, except Apple does, they have their own OS. Anyways, back to what we were doing. Let's share my screen first, and then I'll show you guys the live code. Okay, so we finished auto prepare cats dogs. This should create two, when you run it, it should create two folders. One's cats, the other one is dogs. And it should really be just the two folders of 40 images, I'm pretty sure, each. And this should be pulled from Kaggle. And this is going to be used, these folders of pictures is going to be used to train our neural network and build our model. Student binary NN file basically does the building of the neural network and training. So we basically load the images from the folders. We initialize our weights or the parameters. We have our activation functions, ReLU and sigmoid. And then we do forward propagation, which we won't create here. Oh, we do create here. Anyways, this is for doing the forward pass through the neural network. So computing our weights by passing in uh, our weights through the neural network. Compute loss function, backward propagation function, and update parameters. This is basically just updating our parameters based on the learning rate. And train model, so using all our functions that we made. So for propagation, then doing compute loss, backward propagation, and then we're updating our parameters. Next is predict. So this is using our forward propagation to predict our probabilities. And then we have our save model because we don't want to train our neural network every single time, but we want to save it as a MPV file so that we can load it back up instead of retraining the model every single time. Now, we will create our main function here. So this is basically when we run our file, our Python file, it'll run this function or this if statement, as you guys know. So any code here is what's going to be ran if you run the file. And then after that, we'll continue on with this one. So we're loading the model that we saved. We have our activation functions. We're going to do our forward propagation, our pre-processing of the image, and the main loop or if statement. So this one is basically predicting so we're running this Python file, we're passing in an argument, which is going to be a picture, so like a cat or a dog, and we're going to basically pass it through our neural network model, and we're going to use that to kind of predict what this picture represents. Is it a cat or a dog? Now let me show my live share. And paste in chat. And I'll also send you guys the GitHub so that people who want to just copy and paste the code or download the folder, they can do that as well. Okay, share it in the chat. So please get that open. And let's start with Albert. And after Albert, Charlie, you're next. So just be ready. And Albert, whenever you're ready, open up student underscore binary underscore nn dot py. NN stands for neural network. Yep. And then go down, way down to if name equals main. It'll be the last one, last if statement. Yeah, down. Yep. So step one, let's read through it. Step one, define the image size that we want to work with. So just do 32. So this is 32 by 32 pixels. Step two, we want to load the data and obtain. It's actually after image size, let's make a new line. And let's also define our hidden size. So all caps hidden underscore size equals 64. Enter. Epochs, so EPOCHS, all caps. So we're basically defining our macros here. Yeah, let's also, yeah, have it. Yeah, let's also define our learning rate. So LR, all caps, equals 0.1. Yep. And then we load our images, X-train, X-test, Y-train, Y-test, load image. Yep, that's right. And then next we do step three. We want to determine the size of the input layer. Equals image size. Yep. And then we want to do enter. Step four, pick a size for the hint. Oh, we already did that. You can delete that. And we want to train our model. So for that, do parameters or train parameters equals or params equals train underscore model. We want to pass in our X train, Y train. Yep. Input size is our input size. Hidden size is our hidden size. And then epochs. Yep. Everything's right. And then we want to go to the next line. Step four, we want to obtain our predictions. So just do Y underscore pred or prediction or equals our predict function, and we pass in our test parameters and our training parameters. So that's good. Now we want to do compute accuracy. So we're going to do accuracy equals, yep, numpy dot mean. NP means numpy because I'm pretty sure we're doing import numpy as NP at the way top of the file. And we're accessing the mean function. Yep. And then we do Y predictions equals Y underscore test. And then we want to print it out. So we do test set accuracy equal or colon accuracy. And the dot for F means the last four after the digits. And print to final accuracy, that's already done. So we want to save the train model. So do save underscore model. Yep. And we pass in params, image size, and hidden size, and the file name. Yeah. Now that's good. Even if you run it, it won't work because you don't have the cats and dogs files, right? Do you want to run the cats and dogs if you want? It's right there. Week 8. Yeah, you can. I'm pretty sure it's cats and dogs. Dots. Is the whole file done? Is this my? I'm wondering why. Okay, I think it's easier if I share my screen. Student turn source. Nope, source. And let's run our student auto prepare. Yep, and it should work like that. I'm not sure why yours didn't show. I don't know. Anyways, oh, maybe your virtual environment isn't set. Anyways, but yeah, that's how it should do. And then your binary. Did I run the wrong file then? Let's try it again. Delete. Not solution. Code. Run this. Yeah, it should work. Yep. And it should be cats here, dogs here, and then do binary neural network. And it should work. Yep. Anyways, it should work like that. Oh. Oh, did you clone my repository? What was it? Albert? Okay. Maybe could you git add dash A, capital A, git commit with a message, and then push with your newest change? Uh, it's up to you. But yeah, I'm not sure why it didn't work for you though. Maybe it's the virtual environment, something like that. Yeah. Git, if you want, you can do git add a git commit Albert's commit or something. Main function, git push. Up to you. And then Charlie, can you share your screen and we'll do student underscore binary underscore predict. So Albert, that just makes it so that your code gets pushed under your name. Okay. Mm, oh, you're on the website while I share. Okay. So, and then what do we want to do? Oh, sorry. Predict. We'll do predict. And I'm pretty sure we haven't done the whole file. So let's do load model. So let's start with load model. And you can get started. Yep. Load the MPZ file. So do data equals np.load. Oh, Albert, the reason why is it needs SSH, but you didn't set up SSH with Git. Ah, uh, okay, 1 second. Cloning website. Okay, if you know what? After this class, I'll send you guys, or next week, I'll send you guys the exact commands to connect with SSH for the GitHub repository, and then you guys will be able to contribute to the class GitHub repository. Anyways, np.load string model.npz. So that's the type of the model file. So step 2, we want to create a dictionary called parameters. So just do parameters equals dict, and dict is a function. So you can either do that, or you can do just the curly bracket. This is fine. This is fine. No, without the dict. But you can just do the dict function. Yeah, that also works. And then enter. Next line. Weird. Why is it saying following me? Yeah, and then do parameters, and then when you're accessing or assigning a value to the dictionary's key, we're gonna do the square bracket, and the key is gonna be a string. So do string, and the string's gonna be capital W 1. So the weight 1 equals data's weight 1, and data is also a dictionary. And it gets load from that model.mpz file. So the model file is basically just a whole bunch of weights. Enter. I mean, weights and other data, but enter. So there's going to be more parameters that we want to do. So just the same thing, parameters, but now B1, and it's lowercase, equals data under like lowercase B1. Now I would, yep, B1, and I would copy those two file lines and paste it. Allow. Oh, Oh my gosh. Switching so much. And switch it to W2. So just do B2, W2. Yep. And then return the dict and the two ints. So first, uh, even before that, let's do holy sonum. Okay. Is that better? So do image underscore size equals int function data square bracket, and the key is going to be image underscore size, which is a string. Yep. And copy that and do the same for the hidden size. Yep. And we're going to return parameters, image size, and hidden size. And delete the pass, although it doesn't matter, but yep. And we can stop sharing. Now, now, if you want, the SSH thing is sent in the chat. Uh, so basically, when you guys want to authenticate with Git to be able to contribute to GitHub repositories or stuff like that, you guys are going to want to do SSH connections. So there's three types, right? One, you can download all the files, which should be taking too long. One, you can use HTTP to clone your repositories. While it's easier to just pull and read through the code, you can't contribute to it since you're not authenticated, right? So the third option is SSH. When you guys go to university, you'll use SSH a bit more. I mean, you guys don't even use GitHub until university, right? So, anyways, so for this, you're gonna want to do choosing your operating system. So I'm a Mac, so I would do open up a terminal, copy and paste all of these commands, where your email at example.com would be the email link to your GitHub. But once you're done with this, you're going to be able to contribute to your repositories. Doesn't Up to you guys to do it if you guys want, though. Anyways, next. James, if you can share your screen. And we'll do three easy functions. Yep. And Jordan, you'll be next, so just be ready. And okay, all good. Take your time. And another thing is, yep, And yeah. And when you guys do like hackathons later on, you'll also be using GitHub a lot when you guys work with other team members. So it's just good to be getting the hang of it. So you will go to the activation functions, so which is relu, sigmoid. Yep. Relu is just one-liner, so you'll do result equals np. Oh, it says right there. Np dot maximum of 0 and 2. And we're going to want to return that. Yeah, you can do that as well. Just pass, delete. Next, sigmoid, also easy. Result equals, or you can also just do return 1 divided by bracket 1 plus exponent of, oh, so it's going to be np dot exp. 1 plus np dot exp, yeah. And minus z, the parameter that gets passed in. Yep. Next is for propagation. So delete the pass. Let me scroll down for you if it keeps jumping back up. Step 1, make sure that holy, unpack the weights. Yeah, I don't know too. I'm not even opening up that Visual Studio Code. Anyways, NP, actually delete that. All you need to do is really just doing the same thing, accessing that dictionary that gets passed in, which is parameters, and setting it to our W2, W1, and etc. Yep, before that, just do W1 equals parameters W1. And W is up, yeah, uppercase. W1 equals, yep. And then same thing for B1, W2, B2. B1, B is lowercase. That's how he said it. Yeah. Anyways, W2. Mhm. Step 2. Step 2 is compute the hidden layer. So do the Z1 and then the ReLU. So Z1 equals NP dot dot DOT, which is the dot product, and do X, capital X, which is the parameter that gets passed in, comma W1. So uppercase W1. Yep. Plus B1. After the function. Yep. And then remember, do A1 equals ReLU of Z1. Equals ReLU function of Z1 or Z. Or let's just do Z1 and then change the 105, line 105 to Z1. Yep. And then same thing for Z2. We're going to do Z2 equals NP dot DOT. Pass in the A1 actually here, capital A, because basically we're doing the first it goes through the Z1, then the A1, then we're passing in A1 to Z2. etc. And yeah, W2 plus B2. The A is A1, so lowercase a1. That's how he said it. And then we do the A2 equals sigmoid of Z2. Yeah, good job. Now we're gonna want to return the A2. So this is basically passing in our parameters through the model and seeing how it changes, and we're returning that A2. Preprocess image. Oh, you can stop sharing. Uh, oh yeah, Jordan, can you share your screen whenever you're ready? And Liam, you'll be next, so just be ready. And let me know if you guys don't want to share, although I highly recommend you do. Okay. And Liam, whenever you're ready, can you share your screen? Thank you. We will do preprocess image. Let me actually scroll down for you. Preprocess image. So we're basically loading it, loading that image, resizing it. So when we do the run this Python file, we're going to do student underscore binary underscore predict.py, and we're going to paste a string of the location of the image that we want to pass in. And this image is going to be a cat or a dog or nothing. And we're going to let it guess whether it's a cat or a dog. So we're basically doing, okay, using this image path, we're going to load it from the disk, resize it. So the reason why we're resizing it is because our model is expecting some specific image size. And we're doing resizing it, we're normalizing the pixel values, flattening it, reshaping it, etc., just so that it's in the right format for our model or our neural network. The reason being, uh, the images that this neural network got trained on were all a specific file size and normalized or etc. And yeah, that's basically what you guys are gonna want to do when you guys build your own models or stuff like that. You guys are gonna either download it from Kaggle or have a specific camera that you guys repeatedly take photos from. Anyways, I'm gonna stop blabbering and open the image with Pillow and resize it. So step one, what you're gonna want to do is image equals capital I image. No, like image equals capital I image. The reason being that is a class or a library. Image dot open. So it's an image library dot open. The image path. We're gonna pass in the image path. Open is a function. Yep. And we pass in the image path. So image path comes from the parameter of preprocessed image. We see that we have the image path and the image size. So enter. We're going to do image equals image dot resize. So this one is going to be lowercase I. Yep. So inside it, we're going to pass a tuple. A tuple is a circle bracket, and it's going to be two elements, image size, comma, image size. So we're basically saying, okay, take this image and resize it to be the image size by image size, which is 32. So 32 by 32 picture. Step 2, we're gonna now, once we resized it, we're gonna turn it into a NumPy array. So we're gonna do image underscore array equals np dot array, and array is a function. We're gonna do pass in our image. Oh, Kaden is here. Let me invite Kaden. Okay. Hello, Kaden. Okay. np dot array image. And then we're gonna do enter. Next line. No worries, Kaden. And do image underscore array equals image underscore array. And we're gonna divide it by 255. And this is called normalizing. So normalizing our pixel values. Do you guys know what normalizing is? It's making everything, every value to a range of 0 and 1. The reason being, so RGB, okay, how do I explain this? So an image is basically a whole bunch of RGB values, right? Representing each pixel. And RGB is numbers from 0 to 255 and tuple of 3 values. So red, green, and blue. And each of the red, green, and blue have a value between 0 and 255, I'm pretty sure. So we're going to just divide it by 255 so that 0 is 1, 0, 255 is going to be 1. Every number in between is going to be a value between 0 and 1. Anyways, yep. And then we're going to do image underscore flat equals image underscore array dot flatten. Function. Yep. Next line, we're going to do image underscore flat equals image underscore flat dot reshape 1, -1 is going to be the parameters. Yep. And we're going to return that image. So return image underscore flat. And you can delete the pass. Yep. And you can stop sharing. Okay, that's good. Weird. Okay. Can I have the workspace link, please? Yes. There it is. So next, I think we'll get Nicholas. Can you share your screen? And I believe that's the last function. So whenever you're ready, Nicholas, you can share your screen. The last share link is in the chat. Okay, maybe he's not there. Uh, then it's you, Caden. If you want, you can share your screen. Up to you. It'll just be the last main function. Actually, maybe I'll actually let me show you what we did first, just really quick. Yeah, while you do that, I'll just show you what we did. First thing is just finishing. Okay, it's not loaded up yet, but we're just finished the neural network main function. So just calling all the functions that we made to build our model. And then we built load model, which is loading up our model that was trained, our activation functions, our for pass, so passing our pixel values through, our weights through the neural network and arriving at an A2. And then we're doing pre-process image. Although it doesn't show here, we did do it. And it's basically pre-processing the image so that we can train it. So that we can pass it to our model that got trained. The reason being we want to pre-process it so that it's in the right format as our training images. And all you're going to do is just combine all of those together. It sends you to a... That's weird. Oh, yeah. You have to press... Yeah, James is right. So there's going to be a slight pop-up on the bottom right, basically saying, how do you want to join as a guest or linking your account? You can do both, either way. Weird. Do you want to get a link or are you sure? You don't need to. Because I don't think it's the computer's fault. Or maybe try exiting. Okay. I'll send you the GitHub. Okay. Here's the GitHub. Up to you on what you want to use. Although best case scenario is we all start using Git. But I know that that's never gonna happen. Did it work? Yep. Okay, I see. It's your own file. Okay. Main. So first, we want to make sure that the user supplied exactly one argument. So this is basically saying, since this file is going to be predict.py and we're passing in an image and we're using that image, loading it up, passing it through our neural network that we have trained, we're going to want to make sure that the user only passes in exactly one argument, so that image file. So on line 158, yep, we're gonna do if len, which is the function, and we pass in sys.arg v, yep, does not equal 2. Then we want to print, I don't know, just print like, just tab it. You can tab the prints. And then do sys.exit 1. So this forcefully exits our Python instance. And 1 basically means exit failure. And then step 2, we want to grab the image path. So image underscore path equals sys.argv1. And then we want to do load the save model. So just do parameters, comma, image size, comma, hidden size. So parameters, yeah, image size, hidden size equals load model. And load shit, yeah, lowercase function, tab, and then do x equals preprocess underscore image. And hello, Adam.
Hi.
And Adam, we're basically done everything. This is just the last function. So for preprocess image, you pass in image underscore path and image underscore size. Yep. And run a forward pass to obtain the probability of dog. Step 5. So we're going to do probability equals for propagation, and we pass in x and parameters. Yep. And propagation. Yep. Step 6. You can delete the pass. And you do if probability, and it should be probability square bracket 0, square bracket 0. Uh, Close square bracket, open square bracket. And then another square bracket. Yeah, 0. So we're accessing the probabilities first, I believe, row, first column. Equals, I mean, greater than or equal to 0.5. Greater than. uh, yeah. Then we want to print this image is a dog, or up to you. You can tab it. Holy, this is the most laggiest screen I've seen. Okay. And yeah, that's good. You can start sharing. Okay. Okay. Mm, let me. Should I just? Okay. Let me share my screen. Let me. I'll fill out these last two ones. So should be here. There's just these two. Predict. So for this one, you can change the 0.5. It just means if our probability is greater than 50% or equal to, then we're allowing this guy to predict that it's a dog. And then it prints out the probability. If not, if this is less than 0.5, then we're saying that it's a cat. Now, so people that weren't here, let's start from the beginning. Delete, show my terminal. Start with auto prepare. It's actually, and then for this one, there's a lot of printing, so I'll do the solution one. So it shows each epoch, we're doing 99 epochs. Every 10, we're printing the loss function, so the compute loss. And we're seeing that the loss is decreasing, right? It starts off with 69 and then down to 39. And our test accuracy at the end shows that it was 64% right all the time. So you guys can tell that this is pretty bad, right? The reason being we're actually doing only 99 parameters. We actually only have like 40, like not even like 20 pictures, just because we want to run this really quickly for a demonstration. Usually, I mean, I don't even have a GPU running. This is all on the M1 CPU, right? And you guys can tell that this finished in like 1 second. In an actual scenario, you guys would want to increase the epoch size, increase the training data, etc., increase the neural network, how many layers we have. For example, I'm pretty sure I sat down trying to train a AI model for weapon detection on my Mac, and I was sitting there for 3 hours, and I never did it again. So I went up to SFU. They have extra GPUs on their, I mean, they have GPUs on their desktop uh, computers. So I just used that, finish in like 3 hours. But yeah, usually it takes that long. So another thing, okay, we trained our epoch. Now we want to run our predict. So if it is only no parameters, right? We're just calling the Python file without passing in a parameter, then it should tell us that we should be passing in this image.jpg or whatever. Let's just take one of these, I don't know, main coon cubpath. Here's the image file. Enter. It says, okay, it's a cat. And we determined this with a confidence level of 77%, which is not bad, right? And let's try a dog boxer. Okay, that's what the boxer is. Pass it in. And here you guys see a bad example, right? We see that it determined with a 52%, which is bad in itself, and it determined it's a cat, which is bad. But it would avoid this if you guys train a lot more. And here's another example of an American Bulldog. And it says it's the dog with a 90% prediction rate. Now, the other thing that I want to show you guys, another kind of question you guys might have is why is the system, the argv, does not equal to 2 instead of 1 argument? The reason being is that the first argument that you pass in, it determines, it's not the Python, right? It would be the binary and then .predict.py. So this is the argument 1, and then this would be argument 2. Now, argv comes from C++ or C. I don't know if you guys want to even hear about this, but let me share my screen and then. So let me share my screen. When you guys go into C, you guys will see like int main. So this is C. So it basically says main function. All files have to have a main function. And we're saying that the return variable of the main function is an int value. And we're passing in int arg count. So this is how many arguments we get. And then we're doing char pointer argv. So this is where it basically comes from. Because main function is the main function of every C file. And every C file, you can pass in an argument, and you can get it by doing argc for the arg count, how many arguments you receive for that file. And you can access the arguments using a list of arg values. Another thing why I'm saying this is a lot of AI models use Python or C or C++, just because C is way faster, right? C is way more efficient, etc. And that is it for our neural network. So you guys can see the solution in solution week 8. So you'll see how to run it. So you're going to want to create your virtual environment. So once you create it, you're going to activate it and then install the prerequisites. The reason being, or reason why we use virtual environments, is so that sole purpose of having the installation libraries and separating it from our global Python executable. And then you're going to also want to place your Kaggle API key. So this is for bringing the images from the website. You're going to do auto prepare cats dogs to create the cats and dogs folders. Binary neural network, so training the epoch, so the neural network or the model. And then you're going to test the new model on a new image. So running the predict file and passing in the image. Next. Where were, oh yeah, here. Further project recommendations. So every project, I'm giving like 3 recommendations, right? So first thing you can do is just try out whole different things you can do with like tuning and data augmentation. Or things like pre-processing the image, right? You guys can try like random S flips. So when you guys train models, you guys are gonna want to do like training the model on different types of images, right? Just so that you guys can get a wider range, so that the model can be trained on wider range of images. So you guys can try randomly flipping these images, having rotations, etc., and see if it makes the model better. You guys can try building a front end, so using Flask, which is a Python library or framework. I'm pretty sure Flask is used for server, so the server API, as well as the web endpoint, the web UI. So you can just wrap the model that you trained into a tiny web application so that user can basically drop in the image and it becomes the same thing, right? You just load the image, run the prediction, and then print out is it a cat or a dog. I mean, once you guys get the hang of this, it really everything just becomes repetitive. Next, you can do extend it to a multi-class, so more than just a dog or a cat. You guys can extend it wild animals. And yeah. Does anyone have any questions? And have you guys tried any of the further product recommendations for the other projects that we did? I mean, we solely focus on AI ML, so I never really get to teach you guys how to do web stuff, right? Or servers. If you guys don't have any questions, we have some time, like 12 minutes to do something. Maybe I can teach you guys something that you guys are curious about, if you guys want, or we can just go straight into another project. What do you guys want? Another project for 12 minutes? Or we can just do Blicket. You know what? Let's watch another Fireship then. I think that's a good idea. Mm, Let me actually stop sharing, recording though. Stop